Hello everyone, let's do some problems on the Hess's law. Watch the video on what is Hess's law, and in this video we're gonna do two problems that would show you how to solve problems to solve for delta H of a given reaction. So for example, you are asked to calculate the heat of this reaction, the combustion of methane gas. So this is the reaction that you are given, and you are asked to solve for delta H of this reaction, right? So how do I do that? So I am given a bunch of reactions, right? And the delta H of each of these three reactions. So my first step is I have to use these three reactions in order to make this equation. So it's just hit and trial. So you are given three reactions and their delta H values. So I am going to manipulate these three reactions so that when I add all three equations, I should be able to get this equation, right? So how can I get to this equation? First, look at what are our reactants. Our reactants are CH4 and O2, and the products are CO2 and H2O, right? So you have to make this equation from these three equations. Now look carefully. We have methane on the reactant side, and in reaction 1, methane is on the product side. So I need to change this equation, reaction 1, so that methane becomes my reactant, right? So what do I have to do? I will flip reaction 1. So reaction 1, so let's flip reaction 1. So what operation do we need to do to reaction 1? Reverse it. So reverse reaction 1. So if I reverse, I have to change the sign of delta H. Now my equation 1 becomes CH4. Now it's on the reactant side, and the products are C plus 2H2. And how does it affect delta H? Delta H is now, it was negative before. When you reverse a reaction, you have to change the sign of delta H. Now it's an endothermic. So reaction delta H for the reverse reaction is positive, right? Now let's see what do we need to do with the second equation. So second equation we have CO2, right? CO2 is on the product side, and in the combustion reaction that we need to solve for, we also have CO2 on the product side. So we don't need to do anything to reaction 2. So I'm just going to write reaction 2 as is. So my reaction 2 is C plus O2, and that makes CO2. Delta H stays the same, which is negative 393.5 kilojoules, right? Now let's see what do we need to do with reaction 3. So water is a product in our given equation, and water is also a product, but we have a coefficient of 2 in front of water. We don't have that in the given reaction, right? So we can multiply reaction 3 by 2. So you can multiply reaction 3 by 2. Okay, so that now my equation becomes 2H2 plus half O2 times 2 will be O2, and on this side we will get 2 water. Now do the same to delta H value. So you have to multiply delta H by 2. So 2 times negative 285.83. Okay. Now what I do is add all the equations. So just add all the equations. Add 1, 2, and 3. Okay. So when you add, you can see that we have carbon on left hand side and carbon on the right hand side of the equation. So this cancels out. Their coefficients match, right? What else cancels out? We have 2H2 on right hand side and 2H2 on the left hand side. Common terms will cancel out, right? And then you add all the reactants on this side. So we have CH4 plus O2, 1O2 plus 1O2, 2O2. And on the product side we have CO2 plus 2 water. Now add all the delta H values as well. If you add them, add all of them, right? So what do you get? I got negative 890.36 kilojoules. So this is the delta H value of the given reaction. Let's do another example. In this example, you are given this reaction for which you need to solve for the heat of the reaction or energy of the reaction. So delta H needs to be solved for. And the given two equations are this and this. You are given two reactions for, and then you have to use these two reactions in order to get to this equation. So what change do I need to do to reaction 1? So look at reaction 1 carefully. So reaction 1 is half N2 and half O2, that gives NO2, NO, right? And NO does not appear on any of these, right? But what appears? We have N2 and we have O2, right? But they are on the product side. So these are the products here. Whereas in the given reaction, reaction 1, they are the reactants, right? And we have half N2 and half O2. But here we have one N2 and one O2. So we need to make them whole, and we also need to make them as products, right? So to reaction 1, what change do I need to make? I need to flip or reverse the reaction so that N2 and O2 become our products. So flip, and also I need to multiply this whole equation by 2. So you need to flip reaction 1, and you also need to multiply by 2, right? So my reaction 1 becomes, when we flip it, it becomes NO, and when we multiply it by 2, so it becomes 2NO times, 2NO, and then on this side it becomes N2 plus O2. Okay. So what did we do? We flipped reaction 1 and we multiply the reaction 1 by 2. So this is what we get. Now we have to do the same thing to delta H. Delta H is positive, right? So it will become negative, and we also have to multiply that by 2. So negative 2 times $90.3. Okay. Now let's see what we need to do to reaction 2. So reaction 2, we have NOCl on the product side, and look, we have NaCl on the reactant side, so we need to flip. And when we have 1 Cl2 and we have half Cl2, so we need to multiply this whole equation by 2, and we need to flip reaction 2 as well. So reaction 2, flip, then multiply by 2. So my equation becomes NaCl, 2 NaCl when you multiply it by 2, and on this side I will get NO, 2 NO plus Cl2. Same thing, we need to do the same thing to delta H. Delta H you have to flip, so delta H becomes positive, right? So delta H becomes positive, and you need to multiply by 2. So 2 times 38.6, right? And then what do? We add these equations. So let's add. So you add reaction 1 and reaction 2. Okay. So when you add, now let's look for the like things on both sides. 2NO and 2NO cancel out because they are on the opposite side with the same coefficients, right? It's like X and X on both sides of the equation, they cancel out, right? And then add the remaining. So we have 2 NaCl on the reactant side, and on the product side we have N2 plus O2 plus Cl2, N2 plus O2 plus Cl2. And then when you solve for delta H comes out to be negative 103.4 kilojoules. So this is our answer. Okay, hope that video was helpful.